While I went through an example of a many-to-many relationship earlier, it's worth going through again, particularly if you're new to database design. So I had used the example of author and book, that one author could write multiple books, but also one book could be written by multiple authors. So this is a many-to-many business scenario. And I'm going to use a different business problem to describe it this time around. In this case, a database for a training center. So let's imagine we have two tables right now, class and student. Class includes information like a title of a training course, what date it's on, what classroom it's in, and the student is just exactly the information you would imagine, first name, last name, email, and so on. And what I want to describe is a relationship between them, that a class can be attended by multiple students, but that also a student could take multiple different classes. It is a many-to-many relationship, and I cannot add one column to either table that would successfully represent all the possible combinations. Because if I add a student ID column to the class table, then I can only have one student in each class. If I add a class ID column to the student table, then I can say that each student can only take one class. So once again, in a relational database, you cannot represent a many-to-many relationship directly. You need to create a new table to link the two. And there's several names for this kind of table. A join table, a junction table, a linking table, a bridging table, a cross-reference table. It really doesn't matter, whatever you prefer. And by convention, the name of this table is just usually made up by taking the names of the two tables that it's cross-referencing and putting them together. So in this case, class student or student class either would work. And there's a one-to-many relationship from class to the class student linking table, and another one-to-many relationship from the student table to the class student table. But this linking table doesn't contain any other data than just two columns. One of those columns is a foreign key to the class table with class ID. The other is a foreign key to student with student ID. And this is how we represent a many-to-many relationship. So if I want to take student ID 102, Viola, and say that she takes multiple classes, then what I need is multiple rows in that linking table, both referring to student ID 102, but referring to different class IDs, in this case 441 and 442. One student, multiple classes. And if I want to go the other way, taking one class, say the database design class, class ID 441, I'll take that over into the linking table, find all the rows with 441, find the students for those rows, 102, 101, 103, and just map those to the student table. One class, multiple students. So is this a little more tedious than just having a single one-to-many relationship? Sure, but it's the only way that we can represent this kind of cardinality. Now, one question you might have about the class-student linking table is, what is the primary key for it? Do we need to add a new column? Well, we could add one, add an automatically incrementing primary key, but we're unlikely to ever use it. This is one of the cases where we could just tell the database that we're going to use a composite or compound key, but neither column by itself would be enough to make any row unique, but both of them together would. There should only ever be one row with a particular student ID for a particular class ID. Class ID can repeat, student ID can repeat, but both of them together won't. And that's enough to make every row unique. Now, one more thing. Now, first, I'll recap that quite often you begin by thinking a relationship is a typical one-to-many, and only later realize it is in fact a many-to-many in disguise. One reason for this is that the relationship in many-to-many isn't always weighted equally. Let's say that in your organization, one department has multiple employees who each work for only one department. That would be a one-to-many. It's easy to show and easy to represent. You would make it so each employee row just gets a department ID, and you're done. But if there exists that one employee who's supposed to be splitting their responsibility across multiple departments, and you need to represent that in your system, then this is simply not going to work anymore. It's now a many-to-many relationship, and you would need a linking table to be able to contain that in your system.